Hello, and welcome to today's webinar, Design Challenges to Adopt Ethernet in Commercial Transportation. I'm Lisa Arrigo with SAE Media Group, your moderator for this 60-minute webinar. Our speaker is Paul Reel. Paul is a product manager at TE Connectivity with 25 years of experience in the industry. Paul has been focusing his efforts on bringing data connectivity solutions based on automotive Ethernet and the latest coaxial protocols to industrial and commercial vehicle customers. After his presentation, we'll have a Q&A. If you have questions, please send them at any time by using the questions box. And now, please join me in welcoming our speaker, Paul Reel.
Thank you, Lisa. Good afternoon. Good morning, everybody. Thank you for joining the webinar. And without further delay, we'll go ahead and start. And an introduction of what we'll be covering over, let's say, the next 45 minutes, and there will be time for questions at the end of the presentation. We're going to talk a little bit about TE Connectivity, the company for which I work, and give you a brief overview of what we do in the interconnect industry. We're going to talk about market and application overview, specifically for the adoption of Ethernet in industrial and commercial transportation. And we're going to look at the challenges faced in that industry by vehicle OEMs in adopting automotive Ethernet in the vehicles and the projects that you may have ongoing today. And then we'll talk about how the TE products that are currently released or in development are designed to help with that implementation. So as we look at TE Connectivity as an overview, our purpose in the interconnect industry is to create a safer, sustainable, productive, and connected future. And we do that by advancing the future of transportation, by making factories and homes safer, by enabling global communication networks, and by revolutionizing medical technology. As we look at TE Connectivity by numbers, you'll see that our sales, we're very much a global company with sales distributed nearly equally across the three regions, Asia, EMEA, the Americas. Transportation is the industry in which I'm working in for TE Connectivity, specifically industrial commercial transportation. For us, it's a $6.8 billion business. We manufacture, as a total company, 192 billion products annually and provide industrial technology leadership with customers in over 140 countries around the world. And as you look at the numbers here along the bottom, 20% of our sales are developed and come in every year from new product development. That's very much where I'm focused in developing new products, in conjunction with 7,500 engineers globally, a research and development budget of $610 million, and about 15,000 patents that are granted or pending. So in order to provide 20% of sales from new products, we are very much focused on what our customers are needing in terms of technology to support the direction in which their industries are moving. As we look at industrial and commercial transportation, the business unit that I am working for, the markets that we serve here include on-highway, the trucks, buses, emergency vehicles, anything that is not a passenger automobile. We serve off-highway for construction, agriculture, industrial trucks, and we serve the recreational automotive or recreational transportation industry for leisure marine, recreational vehicles, two-wheelers, and power sports. So by making vehicles and equipment smarter, safer, greener, and more connected, we're providing a complete connectivity portfolio offering 2.9 billion products that we sell each year to this industry, with a global presence of over 10,000 customers in 140 countries. So from a size, a scale, and an expertise and credibility perspective, we want to be your partner of choice when you look for interconnects to address the needs of your industry, and in this case specifically, implementing Ethernet in industrial and commercial transportation. As we now move to a market and application overview, remembering now we're in the industrial commercial transportation space, we've got a lot of market trends that are driving the growth for data connectivity. The landscape is changing from what has traditionally been a CAN bus communication protocol through vehicles. Now that system will likely remain for decades to come because it serves a purpose for low-speed communication. But with the advent of new devices and new needs for things like driver assistance and automation, infotainment options, 360-degree camera systems, high speed both for vehicle to vehicle, or V2V as it's called, or V2I or V2X, which I like to refer to as vehicle to vehicle or vehicle to everything, communications, keeping track of where all of the vehicles are on the road and transmitting data up to the cloud. There's a wide range of essential safety features that are now being integrated into commercial vehicles that require speeds and data connectivity much higher than what CAN bus traditionally can offer. As we look at one of our first offerings here in the next few slides at 100 megabit, we're talking about a 40 times increase in the speeds of connections to be able to support these higher bandwidth, higher data requirements that are moving into the industrial and commercial industry space. And the challenge there is then these new products need to be able to work well in harsh environments. We all know both on-road trucking, transportation, construction, agriculture, where those vehicles are under severe vibration and mechanical shock on a daily basis. There's a need for higher withstanding of dust, dirt, and moisture in operations where vehicles are sitting outdoors 24/7, 365 days a year, and not tucked nicely in a garage at night as your automobile may be. They're operating in temperature ranges from extremes of minus 40 C to as high as 125. And there's also a greater need because of the usage of these vehicles to be able to maintain them in the field and not have to bring a construction vehicle or an agricultural vehicle back to a repair facility in order to repair something when it goes wrong. There's a significant need to be able to repair on site these types of vehicles, including connections and data connections. So the applications that are driving the market for higher speed data connectivity, again, above and beyond CAN bus, are in the infotainment and vehicle dashboards, entertainment, media networking, as we talked earlier, vehicle networking for vehicle to vehicle, vehicle to cloud, diagnostics and preventative responses, telemetry, radar, LiDAR systems, and advanced driver assistance. So all of that provides a need for higher speeds and devices to be able to accommodate that higher speed bandwidth. So the proliferation of data-intensive features is really behind the explosion in data connectivity in the industrial and commercial transportation space. As we look at now transferring the needs for that higher speed data in a harsh world, the automotive-led advancements that have been made in high speed bandwidth adoption are cost-effective in truck and bus applications, but they provide certain challenges. So we can address with a lot of the technology that was developed originally for the automotive industry, passenger cars, generally unsealed connectors, being able to run at higher speeds for these types of products, telematics, advanced driver assistance, cameras, antennas, displays. We're now moving into an environment where there's a need for being able to accommodate that higher data connectivity in much harsher environments. So more robust connectors, connectors that are able to withstand much higher vibration levels consistently, much more weatherized to be able to provide higher levels of ingress protection against moisture, dust, and dirt, and that have the features and benefits that are really required to work effectively in the industrial commercial transportation space and fit in the types of vehicles that are functioning within this industry. As we look at a typical truck application here, you'll see in the upper left, as we go from left to right, the implementation of numerous cameras as vehicle safety becomes critical, both to provide information to the driver of the vehicle, also to provide information back to, let's say, the main office to be able to identify where the truck specifically is. We have a number of connections that are coming from the outside of the vehicle on a camera, having to go through a pass-through on a door or a firewall, and you'll see, and we'll address this here shortly, those pass-through connections often require then a connector that is designed specifically to mount into a panel and be secured, so that if you think about a pass-through in a door truck, you don't want to, over the course of multiple months and years of driving, to have connections that are now vibrating loosely inside of the door panel as you're driving down the highway. There's specific needs in industrial and commercial transportation to be able to securely attach those connector systems in a panel, in a door, for example, or through a firewall. And those types of products today in the automotive environment are really not even addressed. And that's what we'll be addressing here as we talk further. And you'll see the connections then that are required to go to a trailer connection, a rear camera, additional radar and safety devices. Most of the protocols today in automotive Ethernet are addressing a 15-meter max channel with 4 inline connections. So you're able to connect 4 different individual cables up to 15 meters to drive a signal from a device back to the control unit. For commercial transportation, that 15 meters, as you look at going from the front of a truck to the back of the trailer, or from a large construction equipment or a agricultural tractor pulling an implement, the length of those interconnects are extending beyond 15 meters. And so we'll talk here shortly also about the applications where up to a 40-meter link is required to run high-speed automotive Ethernet because of the size and applications of the vehicles in the industrial commercial transportation industry. And you'll see there's a variety of coaxial connections. UTP, SDP, if you're unfamiliar with that, is unshielded twisted pair or shielded twisted pair. Oftentimes, shielded twisted pair is chosen for higher speeds, up to 1 gigabit speeds, or in applications where there's a lot of additional noise, EMC, EMI emissions coming from the vehicle that may impact the signal. So shielding is available on a number of connectors to provide that security of the data protocol that's transmitting over that channel. And in a lot of other cases, an unshielded twisted pair application is sufficient. So as you look at the content growth in trucking from the cab to the chassis, it's really driving products and need for products that support these type of harsher environments with sealing and robust construction. As we move on now on to look at a construction vehicle. Similar types of applications, but you'll see the need for a GPS connection, a cellular connection out to be able to allow communication back to the driver, various radar and antenna applications, displays for the driver, again, to ensure security, an extension, let's say, for the arm of the equipment, so to provide safety device to ensure that as it's reaching up, for example, it's not going to hit a power line. So cameras and other sensors that are on the end of that extending arm can offer additional security. And of course, now we're talking about connections that easily exceed 15 meters in length as you go to some of the larger vehicles where that extended length requires a connection for high speed, but 15 meters just isn't going to cut it. So 40 meters is really what was put into place for the IEEE 802.3 specification to address industrial commercial transportation equipment, obviously much larger than your standard passenger automobile. So for construction and off-highway vehicles that require enhanced sealing and construction to withstand the extreme and long lifespans and the longer channel lengths that come into consideration when we're talking about the size and the applications of a number of these vehicles. So what are the challenges faced specifically by industrial and commercial transportation OEMs? As we look at the automotive Ethernet connectors that are available today, and you'll see here pictured to the right, this is the TE Connectivity's MateNet product line, prolific in the automotive industry, and you'll see it's very, very small, small latches, multiple ports for multiple connections within a vehicle. And here in the automotive industry, the goal was not just the higher speed capability, but was also very compact size, very tight spacing to take up as little real estate inside the vehicle as possible. And in most cases, these are unsealed connections, as in most of the data connectivity hubs and communications are tucked nicely inside the warm and air-conditioned interior of the automobile itself. So with those in-cab connections and the size constraints, we've developed a number of products that work very well from a high-speed data connectivity perspective, but then how do we address the need to put these into packaging that offers the robustness, the sealing configurations, and the other requirements for industrial and commercial transportation? So some of the typical scenarios from a design perspective, as we looked at that truck early on and talked about the panel mount going from between the cab and the chassis, or going from through a door panel. So bulkhead mounting, the ability to securely attach a connector to a panel to prevent vibration during the life of that connection. There's a need for these types of devices to go through the bulkhead and the panel, minimize the space required, and to be able to securely attach those connectors directly to the vehicle and not leave them hanging on a cable that has to be attached to the sidewall somewhere. So with that bulkhead mounting, then we're able to reduce costs, improve installation and speed up installation, and improve serviceability for commercial vehicles. Down to the bottom left, we also are going to talk about hybrid connections. So individual data connectors are, of course, available, but what's missing for commercial transportation is the ability to combine that with existing power connections so that every time you add a device in a vehicle, you're not having to add an additional connector. So we will address the need for hybrid connections where we're integrating both high-speed data connections as well as providing the existing power connections that are available in the vehicle today. When we look at extreme environments, minus 40 to 125 C, operating requirements for 365 days a year, outdoor usage for vehicles, we have to significantly address the need for more robust housing materials to withstand vibrations and to withstand the environmental conditions in terms of water ingress, dust, and dirt, and the constant, let's say, exposure to the elements, not just water and temperature, but also the amount of dust and dirt that is created, for example, on a construction site. Those connectors oftentimes are hanging somewhere in the chassis. They have to be able to withstand all of that. In most cases, not a challenge so much in automotive. And then finally, channel length, as we talked about, as you get to those large vehicles with extended arms or pulling implements behind a tractor, the automotive data connectivity protocols end at 15-meter channels, so comfortable lengths to address nearly all automotive applications. But for industrial commercial transportation, specifically in construction and agriculture, and trucking to some extent as well, the need for a longer 40-meter channel becomes critical for higher speed data connectivity. So what's missing? As we just discussed, we're missing sealed connectors to meet IP67, IP69K dust and water ingress. We need more robust housing designs to withstand the constant vibration and shock requirements imposed by the typical applications in this industry. We want to be able to mount those connectors directly into a panel, either with a screw connection or a clip connection, in order to better manage wire harnesses and routing within the vehicles and not have to attach multiple wires somewhere along the sidewalls. We want hybrid connector offerings so we can just integrate new data connections in the vehicle without adding additional standalone connectors. So the inclusion of both power and signal in one housing to reduce the need to continue to expand the amount of real estate that our connections are taking up in the vehicle. And then finally, the long channel length support to maintain signal integrity over lengths beyond 15 meters. So how can TE products help with these challenges that the commercial transportation space is facing? We have within our differential Ethernet portfolio developed 3 new products that are addressing specifically the needs for higher speed data connectivity, and still at the same time then offering some or all of those specific types of needs that we're talking about previously. So I'll go through these briefly in this overview so that you have the best understanding of where the products and where the products meet the requirements, and then we'll go a little bit more in depth into each one to give you just a taste really of the types of products and how we're addressing the needs we just discussed. So at the top, we'll start with Enet Steel Plus connectors. This is, let's say, an entry-level connector for automotive Ethernet, where you perhaps can be transitioning for some of your higher data rate needs from a traditional CAN bus architecture to a Ethernet connection. And this runs at 100 megabit speeds or addresses the 100 base T1 specification of IEEE 802.3, utilizes unshielded twisted pair cable, works up to 15-meter lengths with 4 inline connections. So again, that would be a total of 5 cable assemblies over that 15 meters with 4 linkages between those, as well as the connections to the board on either end. Maximum temperature 125 C, specifically really applications addressing the agricultural and the construction industry. And the advantage of this product here is it uses an existing MCON or multiple contact point terminal system developed by our Automotive sister organization and used extensively throughout the industry. So the assembly process is compatible and capable with most harness manufacturers are already using these terminal systems. And there are some specific things that need to be addressed since you're using twisted pair cable in this connection, but this is a connector designed for anybody to be able to terminate, to secure, and get a high performance 100 megabit application for single pair Ethernet. It's a very small size. It fits within a 20 millimeter tube, if you would. So it's a very small connector, traditional latch and lock with a CPA. As all of these connectors designed for the data connectivity connections for twisted pair cable have all been optimized. So if you think I want to go from, let's say, a traditional CAN bus connection and I want to turn that into an Ethernet connection, I can just take a twisted cable and terminate it to the existing connector, and now I have a twisted pair connection. There are limitations to that, as we are maintaining in the design and construction of these connectors here on this page, we maintain the spacing required of that twisted pair through the connection. So as you look at any high-speed data connection, actually, it's very similar to a speed bump. If you would, let's say, in a parking lot of a grocery store or a shopping mall, you'll have bumps in the road to prevent traffic from moving at too high of a speed. The connector or the links in a 15-meter channel where we have 4 links, those links are effectively speed bumps for the signal that's going from one end to the other. So if you go over a speed bump very, very slowly, you'll not have a lot of problems inside or notice that bump too much. But if you go over that speed bump at much higher speeds, you'll notice the interruption. So these connectors are designed specifically to manage those speed bumps so that as signals are running at higher speeds, as they go over the speed bumps or through the connector itself, the interruption of that signal is very, very small. Putting that type of connection through a standard connector will be like running over a speed bump at 50 miles an hour. So Enet Steel Plus introductory product, heavy-duty sealed connector with MateNet is our second offering. This is a hybrid connector. Here we are integrating high-speed data over our MateNet terminal system and offering power as well through standard connections utilizing MCP terminals in the HDSDS style connector. This connector is also, let's say, upgradable in that it addresses both 100 megabit speeds as well as 1 gigabit speeds, and that transition can simply be made by changing the type of cable that is used for the data connection from an unshielded twisted pair or 0.35 millimeter square cable going to a shielded twisted pair cable of 0.14 millimeter squared. Your channel would be able to move from 100 megabit performance to 1 gigabit performance in the same connector, no change to the connector whatsoever. This connector itself is capable up to 125 C. A lot of these max temperature requirements are also determined by the type of cable, and so they are cable dependent also in terms of the max temperature range that you can run. And there are a number of different cables on the market for addressing your specific temperature needs. This hybrid arrangement, and we'll go a little bit more in depth in the next slide, is offered through 3 specific housing sizes and multiple configurations within those housing sizes. So you have the ability to go from 1 to 3 Ethernet connections in a connector, and as many as 12 additional power contacts in the various sizes that we'll have on offer. And then finally, at the bottom, we have our DT high-speed connector. This connector is designed for at 15-meter lengths, multi-gig applications, and at 40-meter linkages, 1 gigabit applications, using a 0.35 or 0.5 actually millimeter squared shielded twisted pair cable at 40 meters is able to achieve 1 gigabit speeds and manage those high-speed connections for cameras, for other devices in much larger vehicles at longer lengths. It uses existing size 20 Deutsch terminals, making the assembly process very capable for any harness maker that is currently using any of the TE-DT type contacts for other types of power connections in the vehicle. Again, long lengths and multi-gig for the DT high speed. So what we're trying to do in the development and release of these new products is to provide the right product for the right application, to where you can size for your specific needs now, you can size for the ability to upgrade into the future with a hybrid connector such as the HDSC MateNet connection, where you can transition seamlessly with just a cable change from 100 to a gigabit type of speed. And to address what we talked about earlier in the presentation is also the needs for field maintenance and applications. Imagine a 40-meter link that is broken or damaged and needs to be repaired, and you now have to take that enormous vehicle to a repair location in order to fix that 40-meter link cable. Critical in the application becomes impractical, and so as we've designed these connector systems, we've focused specifically on being able to say, what do our customers need and what are the requirements in these types of vehicles? And this connector then specifically offers the ability to repair it directly out in the field. So let's look on one or two slides for each of the products, just a little bit more in depth to give you some more idea of how these systems are working. This is the Enet Steel, again, 100 base T1 entry level, let's say, for moving from a traditional TX or two-pair Ethernet connection to a single-pair Ethernet connection by shifting to a PHY that supports Automotive Ethernet. 100 megabit single pair, utilizing an existing MCON 1.2 terminal system with tooling out there in the field out there in the market so that anybody could terminate this connection by following the application spec. Very good replacement for existing M12 or CAN connections. Also, when compared to a more expensive M12 connection, both from a connector cost and from a processing time, with the assembly of all of those wires for your TX connection, simplifies things down to a single twisted pair for a 100 megabit application. And go back just for 1 second, and you can see this is a traditional latching connector. Panel mount options available as a pass-through for inline connections, as well as sealed headers, both for dispense sealant and with integrated silicone sealed clips for attachment to the panel, etc. So no need for screws or screwing down bulkhead or panel mount type of connectors. This is a toolless design. And there you can see the mounting clip option with the pass-through adapter. Again, no tools needed, and accommodates mounting clips and panel thicknesses of 1 to 4.5 millimeters. Sorry. Heavy-duty sealed connectors with MateNet housing. Focused applications, again, pretty much the breadth of what we've discussed earlier in the presentation for cameras, radar, lidar, sensors, network backbone, 3 different housing sizes, different configurations. They're not all presented here, and a wide range of accessories, since this is based on a existing existing TE connectivity product. So the addition of Ethernet into an existing style housing of connector gives you the knowledge that if you're familiar with this connector, it's widely used in the industry. You'll see it attached to multiple vehicles and recognize that yellow latch. Very widely used, large number of accessories, all that work with the same thing. And what we've done is taking out some of the power connectors or the contacts and replacing it with Ethernet, either 1, 2, or 3 ports, still providing power along with that and providing a modular system, which adds for a nice transition to add Ethernet into any vehicle, compliant with both 100 base T1 and 1000 base T1 applications. And there you'll see this is the MateNet housing that enables this connector. Earlier, back in when we showed the Unsealed Automotive connections, that was the MateNet product line, that aqua colored connector system. So we've taken the terminal system itself, and that terminal system now goes into the fully sealed HDSC net type of product, and provides a robust high-speed data connection in a very robust and proven connector system for the industrial and commercial transportation market. And then finally, the last product that we have is the Deutsch DT high-speed Ethernet connector, designed and based on our DT size 20 terminal system. This is a fully shielded terminal system. So in these connections, shielded twisted pair cabling is desired and required, both for EMI protection. So as you're transitioning a cable over 40-meter length, for example, it's important to protect those signals inside from other emissions off of either power devices or other signaling devices. So the shielded twisted pair cable in this case ensures that those high-speed signals are protected and not being interrupted by any outside noise, whether from the vehicle itself or from other vehicles or other things that may be occurring nearby, for example, on a construction site. 1 gigabit speeds for up to 40-meter channel lengths with 4 inline connections, and higher speed for 15-meter range. This is designed for the harshest of environments, -40 to 125 C, IP67, IP69K compliant, and available with inline connections, bulkhead mount connections, header variations, again, to address those features that we talked about earlier in the presentation. The compliance is to the IEEE 802.3 BP, both for Type A. Type A refers to a 15-meter channel, and Type B refers to the 40-meter channel length. And simplified assembly in that if you can terminate a DT contact today, you would be able to terminate this connection either at a harness maker for your initial harness, or if you need to replace or repair in the field. These connectors will be available in kit form as well to allow you to just basically pull a kit, repair a cable, replace the connector, and you're back in business at your construction site or directly in the fields without having to service your vehicle. And again, the key takeaway from the Deutsch DT high speed is to look at that channel length. So you'll see here the connections up in the left-hand corner from your initial port, generally from a header connection through up to 4 inlines over up to the 40-meter channel for the Type B type of connections. And of course, this also then works at anything less than 40 meters as well, with the full rounding out of addressing the robustness and the needs of the industry. So as we conclude here with my portion in terms of talking to you and not hearing your questions. Key takeaways is that the automotive-led advancements are making high-speed bandwidth adoption possible and cost-effective in industrial and commercial vehicle designs, but that those automotive connectors are not easily transferable into the industrial commercial transportation space in terms of the connector bodies and outsides of them themselves. They're not well optimized for our industry. So keep that in mind and look to make sure that you're finding connectors that are really designed to address the needs of the industry and not just try to shoehorn an existing automotive type of connector into your vehicle. So the key considerations, as many of us know, is that sealing, the robust housing design, the ability for having bulkhead mounting options for hybrid connector designs that allow for the integration of power and signal without giving up extra board space or extra panel space in the vehicle, and to address longer channel lengths than what is seen in most typical automobiles with 15 meters getting as high as 40 meters. Those are key considerations to keep in mind when looking for the types of connectors to implement automotive Ethernet into your product. And then TE's product and design expertise. We are concerned with customers' channel from start to finish. So we're not just looking at the connector perspective. We work directly with a number of PHY manufacturers in understanding the requirements at the PHY level or the chipset level in transmitting of speeds and ensuring that our connector systems are coordinated and integrated within that type of PHY development so that the signal speeds and performance are not being impacted negatively through our connectors, that our connectors are being tuned and designed specifically to provide a seamless transition to eliminate those speed bumps over that high-speed data connection as you go from one end of the channel to the other end of the channel. And with that, I thank you so much for your attention here over the last 40 minutes or so. And Lisa, I'm going to turn this over to you now to, I'll see if there's any questions coming from the audience. Again, thank you very much, and I'm happy to take your questions.
Plus and the HDSC with MateNet. Paul?
I'm sorry, Lisa, I didn't get your whole question. Could you please repeat that?
Oh, I'm sorry. Yes. Well, first, Paul, I was saying great presentation, and we have lots of great questions from the audience. So we're going to start with this one. Someone in the audience would like to ask you to talk a bit more about the mating cycles for the Enet Steel Plus and the HDSC with MateNet.
So mating cycles for Enet Steel Plus are based on the specific type of terminal that's chosen. So we offer gold and silver connections. So your highest mating cycle would be the gold-plated terminal system, with silver following in second in terms of number of cycles. I don't have that off the top of my head. I believe gold is 100 and silver is 50, but we can certainly reach back out to you and get you that specific information for Enet Steel Plus. On HDSC Net, that is based on our MateNet terminal system, which traditionally is either tin or silver plated, and those specific mating cycles, again, will be dependent on the chosen plating of the interior terminal, and I'm happy to reach out and get you that specific information. Or you should also be able to find that on our te.com website. But we'll take that question and respond to you via email as well with that specific.
Very good. Thank you, Paul. The next question involves the Ethernet connectors. An audience member writes, Ethernet connectors are not pin-based, but have parallel slide contacts. Why are these products pin-based instead of having slide contacts? The USB is all slide contacts as well. Is this related to durability or because the pin-based technology is largely industry standard now? Paul?
That's a very good question. So if you look at a traditional pin and socket type of connection versus, let's say, the suggestion of a USB connector, which is a plated, basically a plated flat terminal either on a printed circuit board, and then it's a generally a single point of contact on the mating contact itself to provide the connection. So for a connection on your PC, for example, to plug in a USB or to charge your cell phone in your automobile, that works perfectly fine. Due to the vibration and the constant motion of a number of very large vehicles, a single point of contact is always a risk in terms of being able to withstand over longevity the types of environments in which the vehicles are operating. So for that reason, you'll see that pin and socket designs, specifically in this industry, are very much standard. And those pin and socket designs with multiple contact points on the connection of the pin and socket itself provide a very robust vibration-proof connection that ensures that your signal is got constant connection and you're able to transmit that data. So especially as you look at higher speeds and the critical nature in which the communication that's being asked for example, providing a visual to the driver in the vehicle, you don't want the risk that that connection is disrupted at any time. And that's really the reason why these are all pin and socket based types of connections versus a USB connection, where under high vibration and wear and tear, as we would see in this industry, there's a much greater risk of failure. And that's why USB in the commercial transportation space is often not looked at. You'll see it in an industrial environment where you have manufacturing and a device sitting on a desktop in a factory. It's very common there, but you're not under that constant load and the environmental requirements of commercial transportation. Good question. Thank you.
Thank you, Paul. The next question is there any clipping provision for the connectors, not for the panels, but just to connect with only bolts and nuts? Paul?
Yes, so on the Enet Steel product, on the smaller HDSC net connectors, as well as on the DP high speed, on the generally on the male connector or the inline connection, we do offer clips that there's a large number of plastic clips as well as metal clips from various products that are already available, that where you can with a plastic clip and a hole drilled in the side wall of your vehicle, attach with a toolless design a plastic clip and hold that connector in place. There's also cable tie options, but yes, all three of the connector systems that we talked about here this morning have clip options on the male side of the inline connection, as well as then specific offerings of allowing a panel mount option or a sealed panel mount option as well.
Thanks, Paul. Another audience member has this question. IP67, IP69K are often not sufficient. I would think a connection needs to be at the very least, IP68 or possibly immersion capable. Are there any plans for a connection system that is immersion capable? Paul?
So IP67 is immersion up to I think it's 3 meters for 30 minutes. So there is an immersion protocol for IP67. A lot of these connectors we have either tested or plan to test to higher ingress protection requirements. The Enet Steel Plus, for example, also has passed the US CAR 2 specification, which has I would say not so much a depth requirement, but it goes through a much longer period of preconditioning, and then it has pressure vacuum testing, both outside to inside and inside to outside. So we do understand the need for constant improvement in ingress protection, and either have or are in the process of testing and improving all of these products beyond an IP67, IP69K type of protocol, and we can certainly always address individual testing requirements if you have specific needs for your specific type of vehicle. None of these connectors, however, are designed to live underwater permanently. They're designed to be within vehicles that obviously have to still operate on dry land where possible.
Very good, thank you. This next question is a two-part question. First, is the Deutsch DT high-speed connectors designed to be used as the connector between a tractor and a semi-trailer? And the second part, is there any limitations in the number of connect or disconnect in the connector?
Okay. DT high-speed connector is designed for single pair Ethernet connection. You could, so where there's a requirement for a 40-meter individual linkage of Ethernet, you could potentially use it between a cab and a trailer if that is the requirement. But we'd have to look specifically at your application. There are other specific, let's say, breakaway. I don't know if you're looking specifically for a breakaway type of system where the connector would disengage and not be destroyed if there was a separation of the trailer from the cab. We have other products in that range, but it could be used for that type of length of connection for a single Ethernet connection. Lisa, the second question I think was that also about mating cycles?
Yeah, let me read that again. Second part was, is there any limitations in the number of connect and or disconnects for the connector or in the connector, such as the connector?
So I think I understand, if I understand correctly, so for a 40-meter channel, that 40-meter channel can support up to 4 inlines. So that would be 4 connections, wire to wire, and then also including a connection to the board on both ends of that connection. So 4 inlines, or a total of 5 specific cable assemblies over that 40-meter length based on the IEEE specification. If you're talking, if the question was related to mating cycles, I think DT high speed with gold-plated terminals is rated up to 100 minimum mating cycles.
Good information, thank you. This next question is about the use of adhesives. Is there a need to use adhesives for sealing processes of the connectors, or are just solid gaskets and sealings needed?
So for the specific connectors that were presented, they all are designed and include silicone seals designed specifically for the mating interface to provide the sealing from one connector to the other, and to be able to pass those specific IP or US CAR2 specifications to sealing. And then in the case of the back of the connector where you have wire or cabling going in, there's also pre-installed seals or seals that are installed during the cable assembly process that provide sealing around the jacket of the cable itself and into the housing that provide sealing features to be able to withstand both IP67 and IP6K9K types of water ingress. So should be no need for additional sealing or epoxying of or potting of connectors. That's why we specialize specifically in sealed connectors and spend a lot of time and resources to ensure that the connectors that we're providing to the market are simple to use, and once you plug in the cable and have everything hooked up, you can plug the connectors in and walk away with the understanding that that connection should remain sealed to outside environmental conditions for the life of the connector.
Thanks, Paul. Another audience member writes, ease of field serviceability is a must in our industry. Do all three product families that you discussed today fit this need?
So Enet Steel Plus is based on MCON terminal system. There's hand tools available for that type of connection. There's a very detailed application spec for termination. It's certainly the choice of the manufacturer, right? In terms of you have to have a technician that understands what they're doing and can follow the application spec and has some level of training in the proper crimping and stripping of wire, and then also a little bit of understanding of the fact that this is a twisted pair cable, and there are certain application requirements that have to be maintained, but nothing that is not easily learned, let's say that. So for Enet Steel, the answer is yes. Everything exists today to be able to cut off the connector in one end and re-terminate another connector to it in the field, so that is completely field repairable. On the Enet or on the HDSE net side, that's a MateNet connection. It is very, very small and would be, let's say, more challenging in terms of a field replacement on the MateNet connection. What we're seeing is that many customers, because of the higher speed, 1 gigabit type of applications, as well as when you move into shielded cabling, the connection, to accomplish that connection, gets a little bit more challenging doing that in the field. So for shielded twisted pair connections utilizing MateNet, we're seeing most customers able to just stock a replacement cable for the Ethernet. The rest of it is certainly repairable, but they would generally tend to replace the Ethernet cable as a whole, as a service item, rather than try to field repair the MateNet connection, although it can be done. And then for DT high speed, because that is a much larger, more robust terminal, easy to hold in your hand, easy to terminate, a large number of tooling out there in the field, those are very much able to be field terminated. There is a ferrule crimp and a shield on the cable that must also be crimped, so 2 hand tools. But that connector is specifically being designed due to the 40-meter linkage as well for field repairability. So just to recap, Enet Steel, yes. HDSE net can be done, but you may not want to get involved in it. And DT high speed, absolutely. Field repairable.
Thanks, Paul. Another audience member wants to know, when do you think the DT high-speed connectors will be available?
DT high-speed connectors in terms of B samples are available now, and you can reach out to me if you would like further information or sample kits. We have those available today. We expect that product to be available and released to the market before the end of the year.
Very good. And with that, we're at the end of our webinar. I want to thank Paul Reel for his presentation today and for answering all these great questions that we've gotten in from the audience. I also want to thank the audience for attending today. For those who sent in questions that we didn't have time to answer, we'll be reaching out to you directly after the webinar. Once again, thanks for watching.